strange planet with a backward, cucumber-shaped orbit is turning into another kind of world. Astronomers have detected an exoplanet with a highly oblong orbit that experiences wild temperature swings, and it may be transitioning into another type of world. The exoplanet, named Ticeta for 1-953 orbits a star about 1,100 light-years from Earth. The star is one of a binary pair, so the planet orbits the primary star, while the primary star orbits a secondary star. Interactions between the two stars, which have a misaligned orbit, could be responsible for putting this planet on the path to becoming a hot Jupiter, researchers reported in a study published Wednesday in the journal Nature. Astronomers have found more than 5,600 confirmed exoplanets, and 300 to 500 of them are hot Jupiters. These planets are massive Jupiter-like gaseous bodies that closely orbit their host stars, which heats them to scorching temperatures. While Jupiter takes 4,000 Earth days to complete one orbit around the Sun, hot Jupiters complete one orbit every few days. Scientists believe the large planets begin by orbiting their stars from a distance, but migrate nearer over time. But they have long questioned how the massive worlds end up in such tight orbits, which are far closer to their stars than Mercury is to our Sun. The observations of Ticeta for 1-953 first captured by NASA's Planet Hunting Test Satellite in January 2020, offer rare, revelatory insights into what may be a planet on the path to becoming a hot Jupiter. Astronomers have been searching for exoplanets that are likely precursors to hot Jupiters, or that are intermediate products of the migration process, for more than 2 decades, so I was very surprised and excited to find one, said lead study author Arvind Gupta, Neurolab postdoctoral researcher who discovered the planet as a doctoral student at Penn State, in a statement. Spotting a changing world on January 12, 2020, the Transiting Exoplanet Survey satellite collected data suggesting that something was passing in front of the host star ticked 141 million to 149,530. TESS monitors the brightness of nearby stars to search for dips in starlight that may indicate the presence of exoplanets. Gupta and his colleagues followed up on the data and determined that a Jupiter-sized planet was passing in front of the star. Then they made measurements using instruments on the Wine 3.5-meter telescope at the Kitt Peak National Observatory in Arizona to determine the radial velocity of the star, or how much the star wobbles back and forth as the planet's gravity tugs on the star. The radial velocity data also confirmed the presence of the same planet and helped the researchers clarify that it was about 5 times more massive than Jupiter and had what astronomers call a highly eccentric orbit. Astronomers use eccentric to refer to the shape of a planet's orbit on a scale from 0 to 1. 0 equates to a perfectly circular orbit. In our solar system, Earth has an eccentricity of 0.02, while Pluto's highly oval-shaped orbit around the Sun is considered 0.25. The newly discovered exoplanet has an eccentricity of 0.94, which is more oblong than any other transiting exoplanet astronomers have ever found, according to the researchers. The oddball world takes about 6 months to complete one orbit around the host star, coming extremely close to the star before flinging out wide, and then coming back to a narrow, oval orbit similar in shape to a cucumber. We caught this massive planet making a sharp, hairpin turn during its close passage to its star, said study co-author Suvrath Mahadevan, the Vern M. Williman Professor of Astronomy at Penn State, in a statement. Such highly eccentric transiting planets are incredibly rare, and it's really amazing that we were able to discover the most eccentric one. The planet is just 3 million miles from its star, more than 10 times closer to the star than Mercury gets to the Sun. For reference, Mercury is located about an average distance of 36 million miles, 58 million kilometers, from the Sun, according to NASA. The extreme orbit causes enormous temperature swings over the course of the planet's year, said study co-author Jason Wright, professor of astronomy and astrophysics at Penn State. The temperature at the cloud tops gets hot enough to melt titanium during the few days it screams past the star close-up, Wright said via email. During most of its orbit, it is farther away, and at its farthest point the daytime cloud top temperature is like a warm summer day on Earth. The research team also discovered that the planet is orbiting backward or moving in the opposite direction when compared with the rotation of its star, a rare occurrence that hasn't been seen in most exoplanets and doesn't happen in our solar system. All the quirks observed about TIC to 141 million to 149,530 b are helping astronomers understand how the planet formed. While we can't exactly press rewind and watch the process of planetary migration in real time, this exoplanet serves as a sort of snapshot of the migration process, Gupta said. Planets like this are hard to find, and we hope it can help us unravel the hot Jupiter formation story, a dance of orbits. The team ran simulations to determine how the planet may have ended up in such an unusual orbit, as well as how it may evolve over time. The simulations included modeling the gravitational interactions between TIC to 141 million to 149,530 b and its host star, as well as the secondary star. The research team estimated that the planet likely formed far from the host star and began in a wide, circular orbit similar to Jupiter. But the host star has a misaligned orbit with the second star, which exerted gravitational forces on the planet and stretched out its orbit, the researchers said. Over the course of many orbits, the gravitational influence of that outer star altered the orbit of TIC to 1:9530 b, making it more and more elongated, Wright said. With each pass of the host star, the planet's orbit loses energy, so astronomers estimate that in hundreds of millions of years, the orbit will shrink and stabilize to last just a few days rather than the 167 days it takes now. Then the planet will become a true hot Jupiter, said study co-author Sarah Milholland, assistant professor of physics in the Massachusetts Institute of Technology's Kavli Institute for Astrophysics and Space Research. It's a pretty extreme process in that the changes to the planet's orbit are massive, Milholland said. It's a big dance of orbits that's happening over billions of years, and the planet's just going along for the ride. Twin hot Jupiters before tick to 141 million to 149,530 b. The only other known early hot Jupiter was an exoplanet called HD 80606 b. Discovered in 2001, HD 80606 b was considered the planet with the most eccentric orbit until the recent discovery. HD 80606 b has an eccentricity of 0.93 and a shorter orbit of 111 days, and it orbits in the same direction of its star. But otherwise, the planets are practically twins, Wright said. Finding two planets in such a brief stage of planetary orbital evolution is like chancing upon a butterfly at the moment its chrysalis opens, he said. Discovering a second hot Jupiter precursor is helping astronomers to confirm the idea that high-mass gas giants transform into hot Jupiters as they migrate from eccentric to circular orbits, the researchers said. The team hopes to observe TIC to 141 million to 149,530 b with the James Webb Space Telescope to uncover the dynamics of its atmosphere and see how it reacts to such rapid heating. And the search continues for more planets such as these transforming into hot Jupiters. This system highlights how incredibly diverse exoplanets can be, Milholland said. They are mysterious other worlds that can have wild orbits that tell a story of how they got that way and where they're going. For this planet, it's not quite finished its journey yet.